Hello folks, belated Happy New Year to you. Had a bit of a slow start to the video making this year because, as you can see, for the first week or two of January we had a tiny little amount of snow here at the old homestead that took up a lot of my time. Now, it's not all bad news though, because due to the fact that I was trapped in literally right here, this is where I'm kind of sitting now up at that window there, making this video for you once all of this snow is gone. But I was pretty much a captive audience in front of the computer for a better part of a week. So the saying goes, my loss is your gain, because guess what? It's finished. Obvious caveats here, we don't know that it works and so on, but our Model 3 drive unit replacement PCB version 1 design and PCB layout is pretty much done. And but that's not all, as they say, because Prototype 0 is currently on the way to me from Germany. A good friend with a Prusa XL kindly lent his printer to the cause, and we have ourselves a 3D printed prototype of our board coming over so that I can check kind of thing that it fits, you know, the same mounting holes, particularly things like where the MOSFET connections are on the inverter, where the high voltage connections are. We can check that our multi-way connector on the back is going to be in the right spot to fit into the socket. We can check the current sensors fit, the temperature sensors will be in the right place. So all the stuff that I would have had to spend money on to get a few bare PCBs made, which had been my plan to do just before Christmas. I'd been kind of trying to get it to a point that, you know, I wouldn't even finish tracking the board, but I would be able to have the board outline correct so we could check it. But thanks to the kindness of this gentleman, I don't need to do that, because now we have ourselves a plastic version, so we'll call this one Prototype 0. So what I want to do, first of all, before we get into the actual circuit and some of the things that I've been doing there, anytime that, you know, over the last week or two that I've been working on this, that I've kind of felt a bit of I've felt a bit negative, or I've kind of felt I didn't just feel that that I was going to get on with it. I just kind of kept coming back to this 3D view and looking at it for hours and just staring at it, and yeah, so that kind of helps me now and again. So let's turn off the old ray tracing, go back to low res graphics for me, and we get rid of that. And if we turn on our copper pores, you'll get to see it in all of its glory. Now I'll come back to this in more detail along with the schematic later in the video. So now would be the time to click pause, go up to the search bar, type funny cats and press enter, and you'll be safely taken away from this nonsense. Yes, speaking of funny cats, Watson, really, I'm trying to make a video here. Thank you. Right. So anyway, what I wanted to do was wanted to show you where we're at in terms of actually ordering working prototypes. So obviously, as some of you will know, I have been working, well, I've been using JLC PCB for some time. They're my go-to for this kind of thing. So if I got my thing here, no, it's gonna make me find it the hard way. One sec, folks. Okay, so got them here. We're gonna go with our Gerber file and let that load up. Now, just before we go any further, just want to make the point, I am not sponsored by JLC PCB or indeed anyone else. And in fact, JLC PCB made a point of explicitly not sponsoring me, indeed for this or any other project. So that's just how things are, I guess, when you're not, you know, super popular these days. But Watson is a very popular cat. So Watson, there we go, Watson tail. So our PCB, this is just based on 5 pieces, and we just go down through all that stuff, turn on assembly. Yeah, top side only, because we are a single-sided surface mount board now, so there's no components on the back side. Well, kind of strictly speaking is, because the main connector goes on the back side, but obviously that's just a hand solder scenario. So we can go on through that, and it's gonna make me find it the hard way. Alright, so let's go BOM in and CPL. Oh, we gotta find this the hard way too. Great. Okay, CPL, we're in. Now when we hit this, it's gonna pop up an error box, and the reason for that is that I haven't cleaned out the through hole components from the CPL file, but that's only it's kind of a housekeeping thing, so we can just ignore that, and hopefully it will populate the BOM. Now again, in terms of the BOM itself, there's housekeeping here. For example, you'll see here that I have some component duplication. This just means that there's lines in the BOM that have the same part. But there's quite a few bits on this board, folks. Quite a few bits. Now there's a couple here that they don't have. So we'll be making a little Mauser BOM for that, and there's a few components down here at the very end, just some caps, resistors, and a diode that I just haven't, I have to just pull them up. I think they're around, yeah, they're around the power supply chip. We just got to pull them off and measure values and plug the values into this BOM, and we should be good to go. And there's one device, the TPS 40211, which is that little programmable current source that they use in the feedback circuit. The JLC don't have at all, so we'll have to, it's not a terribly hard part to fit. It is a whatchamacallit, like it's a pretty big part for a surface mount. It's a SOT23, so it's not terribly hard to hand solder. So anyway, we'll go ahead with this. We just say do not place. Again, that's just housekeeping on the BOM. And what they should do here, if everything works, is it should throw on the components where it thinks that they should be. So first glance here, you'll see that there's going to be some bits that are not going to be populated. Seriously, Watson? No matter what we do. So primarily we're going to have the gate driver chips, the STGAPs, the gate driver power supply transformer, obviously the current sensors. You have to pull off the existing board, and well, there'll be a little DC-DC converter here, and the connector, the multi-way connector. You can probably harvest that off the existing board, or we might actually be able to find that part. So anyway, let's say we were to proceed along here and we say, yeah, that's fine. I just usually just stick this on DIY. I'm not interested in any of the other things, but I just want to show you here is going to be ultimately the price of these prototypes, which is not exactly cheap, and unfortunately I have them duplicated here. Of course I do. Let me get rid of these duplications. So I was messing around with this yesterday. So yeah, that's for 5 prototypes. Now I can stick another 150 euros onto that by the time I get the boards landed here, due to import taxes and VAT and things like that. So looking at about 700 euros to get 5 prototypes, which realistically are probably not going to work for some reason that I haven't yet realized. So what that means for me at the minute is that I'm not going to be ordering these boards straight away. Be a month or two before we can hit this. So what I'm going to be doing in the meantime, obviously we'll be having the 3D printed version to work with. Oh, before I get back to the actual board, I know some of you will say, you know, why don't you try PCB way? Now if we do PCB way, and it makes me work for it again. Of course I'm on video. Alright, so we hit our test Gerbers. We throw the Gerbers into this, what you're going to see is even for the bare PCBs, this just becomes prohibitive, and then it would require a complete, well, not a completely different BOM, but probably different part numbers for these guys and all that. So, you know, I don't think I'm going to be doing anything with these guys either, because again, none of them are interested in sponsoring, either because it's me or it's this project or whatever. I don't know. I don't particularly care. But what it does mean for us is that we will be getting, I suppose, a little bit more time working on the board. Now, before we get into the board, I want to run through a few things on the actual design of the whole thing for you. Now, for people that are more interested in the more backgroundy stuff, that's in previous videos. I'm not going to be getting into too much of the nitty-gritty with this, but I just want to cover a few of the, well, there's really only 2 things that I've done that are massively different. If we look at how Tesla do the power supplies on here, there's 2 power supplies. One is derived from the 12-volt system of the vehicle, and the other one over on this side of the board is derived from the high voltage. Now, one interesting thing that we find on this version of the board, and there's a lot of different versions of these Model 3, Model Y drive unit PCBs out there, and I get the sense that they're doing some optimizations or cost saving projects or simplifications on there. And I went down a little bit of a rabbit hole looking at all of these things, and I would end up having to buy like about 4 or 5 inverters to actually pull them apart and document the differences in there. So I decided to do, instead of that, is just stick with the board that I have, which is the most common. It seems to be the most common design. So a couple of things they do on this version, let's call it, is they have these, you probably see it better on this one, yeah, on a high side one here. they've these kind of current limiting circuits on both the high and the low side gate driver, and they've been eliminated on certain boards, certain revisions of the PCB. The other way is how they generate their let's call it high voltage referenced low voltage supplies. So on this revision of the board, there's a transformer, and there's a Viper 16 switch mode power supply chip that, you know, it's actually quite familiar to me. I've used them in the past for little power supplies, little mains derived power supplies. Now, what I've decided to do on this initial version of the board is to eliminate all that and just use a off-the-shelf DC-DC converter, which provides us with our plus 15 volts supply on the high voltage side, and we just pretty much copy Tesla then using this TLE 4264 low dropout regulator. Now, why are we doing that? Why are we worried about that? You might say, well, if we come up to if we pick any phase and pick the low side, and I'm going to zoom you right in here. So this is our gate driver chip. This is our ST-GAP1AS gate driver chip, and this is the high side isolated power supply input. Now you'll see here we have these two diodes, D491 and D74, and they're connected facing one and another. And we have what I've termed voltage high low side, a primary supply comes in this way, and then there's a voltage high low side supply which comes in through this diode here. So what this means is that on this revision of the PCB, the low side gate driver chips can have their power supplied either via the transformer system here, which is our 12 volt supply, power supply. The transformer I've taken off there, but there'll be a big transformer on there. Or if that doesn't function or fails or for some reason, then you can come along and it will supply it from the high voltage side. Now, this is where I'm not sure, and this is where I'm having to take a guess, which could well prove to be wrong. There's two reasons that you might want to have this particular setup going on here with your low side gate driver. The first one is you might want to have a backup power supply for it. So if you're riding along in your automobile and for some reason the 12 volt system or the 12 volt supply to your drive unit drops out, you may want to have a backup power supply for your low side gate drivers. But be that as it may, another and possibly more reasonable explanation would be this: that you are using your 12 volt supplied, I call it the primary supply here, just to get things started up. Now once the high voltage side, once high voltage is connected to your drive unit, then you let the Viper power supply here, so the high voltage derived power supply, you let that take over supplying power to the low side drivers. Now, a bit strange, you might say, why would you do that? Well, if we look at our gate driver transformer, what we have is, so if we look at our gate driver power supply, we'll see that there are 4 secondaries, and we use 3 of those secondaries, so this one here, here and here, to supply the 3-phase high side power supplies. But that only leaves us one then, this guy here, to supply all 3 of the low sides. So the question is, would I be straining this single winding on the transformer by trying to run the gate driver, by running all of the gate drivers, all 6 chips, solely from this transformer? And there's no real way to know that without trying. I guess, I know theoretically you could get really down into the weeds of mathematics and with your switching frequencies, switching speeds, and how much gate capacitances and all this kind of thing, but to do that would be a exercise in itself, and in my view would never actually, in the way I could do it, certainly wouldn't really replicate real world. So I'm going to try, so you don't have to. So if, and most likely when, I blow up my inverter, we will have determined hopefully what the situation is here. So that was the first thing, all kind of bundled into one. The second thing is around the actual gate driver circuit itself, and I made some notes for myself here, which I'll just run through with you because it may not come out too well. There were some components in the gate driver circuit that I haven't been able to identify. The first is a diode here that is used in part of the what did I call it, the DSAT detection circuit. It's marked VN17. Couldn't find any information on that. However, looking at some of the circuits for the STGAP evaluation boards, I have kind of made an educated guess on that. The next one then we had one was a diode that's marked 2H2. Again, couldn't get any info on that, but again, just looking at the evaluation board schematic, we did get a part number there, which was for a 3 amp 40 volt Schottky. So yeah, just picking a compatible part for that. There was a let me see, a transistor, I think, called G1, and another one called JV. No information on those, so literally sticking my finger in the air for that. And finally, there's a little part of the circuit here that has kind of niggled away at me for a bit. Arthur had worked on this and had found that there's a depletion mode N-channel MOSFET here hooking the high and the low side together. That's this guy here, Q51. Again, absolutely no information on that, so kind of got no choice but to stick my finger in the air and pick a kind of a common depletion mode N-channel part. So BSS 169. Is that going to work? Is it going to blow up? Only one way to find out. Alright, so finally then, that leads us back to the actual board layout. Now, where possible, I've attempted to copy Tesla's layout, particularly around the gate drivers and that kind of a thing. So here, where you see the various copper pores on the inner layers and so forth, I've broadly tried to emulate what they've done. Now, keep in mind that this is the original OEM board, is a 6-layer double-sided, and we are going for 4-layer single-sided surface mount. So yeah, it's been a bit of a challenge getting here, but so where I'm going to be spending a little bit of time now, between now and when I have the funds to order some prototypes, is there's areas around the copper pores and that I want to better optimize. So for example, what we don't want is we don't want right angles on any of the layers like I've got here and this kind of thing, because they allow charge to build up, and keeping in mind that we are trying to isolate high voltage signaling from low voltage signaling, and also isolating 4, you can kind of call it 4 gate driver sections. So for example, here you'll see on the bottom, these are our high sides, the 3 separate windings on the transformer, and this is our low side, what I call primary supply. And then over here, as I said, I'm just gonna try an off-the-shelf DC-DC converter here to see if that's going to work out for us. So I'm just going to throw you back. Yeah, one thing just more on this. What we've been trying to do is just in terms of the board layout. Signals are on the top and the bottom layers. So the red and the blue. And then the more planes where I've had to do pores and things like that. So for 3.3 volts, ground, things like that, I've tried to keep those on internal layers within the PCB. Kind of roughly emulates what Tesla do. But as I said, there's still, there's quite a few compromises, there's quite a few assumptions in here, so yeah, we all know about those. So finally then, let me just throw us back onto the 3D view here for a sec. So if we look at the actual board, where I'm trying to aim for the finished product will be to have all of the small surface mount stuff on there. So resistors, caps, diodes, ICs. I don't think I'm going to be able to get the gate driver chips from JLC. They do list the STGAP1BS, but they don't have any in stock, so I might try and work with them on that. But yeah, they don't seem that keen on the likes of me anymore. When I did contact them there a month or two ago last year, it was talking like, oh, if you order 300 square meters of PCBs, we can do a deal with you. Well, sure, okay. I'm pretty sure anyone could do a deal with me if I ordered 300 square meters of PCBs. So anyway, worst case, you might have to get those gate driver chips from Mouser. The transformer is an interesting one. You can get this TDK VGT transformer from Mouser as well, but obviously if you wished, you could harvest it. You will have to harvest the current sensors. DC-DC converter is a true hole part, that's a hand solder, and finally then we will have the main input connector. So again, you could either harvest this, or I will try to source it. I think you can get this. I think it's a Molex part. I'm not 100% sure, but we'll try and make up the little auxiliary BOM for that. This board will not have a Wi-Fi module position on it. There is a header here where you can connect a Wi-Fi module and or a serial terminal, just for setting up and that, but this board will primarily be used with the external CAN based Wi-Fi system and or the CAN based computer configuration interface thingy. So that's about where things stand, folks. Thanks for bearing with me on this. Kind of hard to believe it's been nearly 5 years getting here. Want to thank everyone that's assisted me with this project in particular, whether it's little or large or whatever, and particularly Arthur for coming on board when I was very much I hadn't forgotten about it, but I wasn't actively trying to remember it. So anyway, the board's done. When funds allow, I will order some prototypes. We will be back to you fairly soon once my 3D printed version arrives, and we'll see that, see how it looks in terms of fitting it into the inverter and make sure that everything lines up. And if it doesn't, well, that's great, because then we can come back and fix the board so that at least obvious silly things won't prevent the board from working. So finally, I guess it's kind of always a bit strange for me that you know that things like this aren't more of a you know, a community project sort of thing. But I guess that doesn't seem, it was never huge in the EV field, I guess, but it just there just seems to be even less of it these days now. But anyway, I am very grateful, as I say, to everyone that does assist, and I hope to be able to bring this project to you folks in a working state as soon as I can. So until then, as always, don't forget to thumbs down this silly nonsense. Don't share it with your friends. Don't do anything with it. Don't watch it even. But do check the links in the description for the Open Inverter Forum. GitHub as well. By the time you're seeing this, I will update the schematic, the board layout, and maybe even the old 3D view up on GitHub. So if you want to have a look at the schematic and maybe leave me a comment what you think, maybe, you know, many minds can solve some of the problems. If you have any info on those components in the gate drive section or anything else that you think I should be doing, because as I say, I kind of have this little bit of enforced pause on here now just due to the prototype cost, so I want to try to use that as best I can. So folks, that's it. I've ranted on long enough, and as I say, we'll be back soon with our 3D printed version no matter what happens. So thank you very much, and we will see you next time. And until then, happy PCB printing.